Kia ora, Union. This video is very much an extension one. We have to write the equations for each of these lines. That's not extension. That's pretty straightforward for most of these ones. But then we have to find the exact intersection points of the lines making up the star. So we can find intersection points by looking for the coordinates where two lines meet. That's doing it using the graph. But we can get an exact answer even when it's not on a blobby point by using some algebra. So in this video I'm going to teach you how to do that, but you're going to need to get confident with doing what we call solving equations with x on both sides. So the first thing I want you to do to speed us up is to pause this video. I'm going to label all of the equations so that we're talking about the same ones. We'll make this one A, this one B, this one here C, and then this one here, the horizontal line, very easy, D, and this last one down here can be E. So there are 5 lines, and then we've got a lot of combinations to work through to find the intersections. So equations that are easy to find here are A is fine, B is fine, D is fine, but C and E, we're going to strike something new. So I'm going to give you a hint on those. Look at equation C, you can see that the y-intercept is not an integer value. It's somewhere in between, what have we got? Somewhere in between -2 and -3. And the same thing happens for equation E. We don't have a blobby point for our y-intercept. So if you see that, what you don't want to do is you don't want to just guess some weird fraction between those two things. We're going to use our brains and some algebra to figure those out. So go and figure out A, B, and D first, and then I'll go slowly through how we can find the equations for the other two. Right, so A, we should get very easily y equals 3x minus 1. And B, we get y equals -3x plus 5. And then for equation D, it's a horizontal line, so the pattern's going to be y equals a number, and it's going to be y equals -1. Now let's take a look at equation C. So we can't work with the y-intercept, but we can still use the idea of the blobby points to help us find the gradient. So we have to find 2 blobby points in here. So we've got one here, and then we just trace our way down, and we're looking and looking, and it's a long time till we get a blobby point, but here it is down here. Right, so we're going to use that to draw out our triangle and do our counting, just like we did with the easier ones. And you can see here we've got 1, 2, 3, 4, 5 across, and then down 3. So that means that I know that equation C has this for its equation. It has y equals -3/5 x plus c. But I can't use the y-intercept by looking to work out what that is. So what I have to do instead is to use the fact that I know 2 of those blobby points. So I'm going to get rid of that stuff there. Let's just think about what we know. I'm going slowly on this because I think for some people this is quite a hard idea to get your head around. Well, we know that this point here has got the coordinates of x is -4 and y is 0. And we know that it has to fit onto this line. So if it fits onto that line, we can use that to work out the value of c. Right, so we can say that 0 is equal to -3/5 times -4 plus c, and that's going to tell me exactly where the y-intercept is. Now that works out to be 0 equals 12/5 plus c, so c is equal to -12/5, which is -2.4. So let's see if it fits. Well, look at that. I mean, it would be bad if it didn't, right? I would have made a bad video. Look, it looks exactly like -2.4, but we couldn't have just guessed that number, right? So we need to be really precise and use algebra to work that out. Okay, so now we've got the equation for line C. So y equals -3/5 x minus 12/5. What I want you to do now, not surprisingly, is I want you to try and do the same thing for line E. I'm just going to get rid of some of my little dots. So try and work out the equation of line E and then hit play on the video when you've done it. Okay, well, we've got the same problem. We haven't got a y-intercept that we can just find easily. So we need to find the gradient of that curve. So let's look for 2 blobby points. I'm working my way along E, going up here. Here's my first one. And then here's my second one. Now, lots of you probably watching this will have seen that there's symmetry in this picture. And you probably can just see by looking that the gradient is going to be positive 3/5, but suppose that you didn't notice that. We can work that out like this. We've gone 5 out here and 3 up here. So line E is going to have equation y equals 3/5 x plus c, but I can't use my y-intercept because it's not a blobby point. It's a non-integer value y-intercept. So I could use this point here, which has got coordinates. What have we got? 6, 0. Or I could be fancy and I could use this one down here. What's this one? Coordinates. The x value is 1 and the y value is -3. Now I'm going to do it this way just to show you that, of course, this will work as well. So -3 is equal to 3/5 times 1 plus c. That means that I've got -3 is equal to 3/5 plus c. -3 minus 3/5 is equal to c. So there I'm doing a little bit of equation solving by doing the same thing to both sides. If you're watching this video, you're probably fine with that. Next, I need to do a common denominator. So I'm going to have -15 minus 3 over 5 is c. So c is a pretty gross -18 over 5, giving me the equation for E of 3/5 x minus 18 over 5. Okay, so that's equation E, and this is equation C. That means that we're all set with our 5 equations, and we can start now to figure out what it means for them to intersect. So this video is going to be probably split into 2. I'm going to do some of the easier intersections in this video, and I'll come back to the bad ones for later on. Let me just put my label back on here so we know that that's equation E. Well, I'm going to start with looking at lines A and B to figure out how we can find the intersection, because this is one where we can do it straight from looking, right? So from looking, we can see that these points meet at the coordinate 1, 2. So if we think about what an intersection means, it means that we have got a coordinate pair that is on this line and it's on this line. So if we're going to do this with algebra, here's what we're saying. We're saying that if we've got an x value of 1, then it's going to generate the same y number in both of those rules. And that's the only place that that's going to happen for those 2 lines, right? Suppose that I put in x equals 3. Well, if I put in x equals 3, for this line, it's going to give me that value for line B, and for line A, it's going to give me somewhere way off up here. So it's a special place where they meet, right? And we're going to find that using algebra now. So we've got our first line is y equals 3x minus 1, and our second line is y equals -3x plus 5. So we want to know where will those y values be the same for an x value. So the y value of the first line is 3x minus 1, and the y value of the second line is -3x plus 5. We're going to figure out what's the x value that makes them the same. First, I'm going to add 1 to both sides, and I'll get 3x equals -3x plus 5 plus 1. So 3x is equal to -3x plus 6. Now, what am I going to do next? Oh, my screen's frozen. Oh, no. Uh-oh. Oh, sorry, guys. I think you can still hear me, but my laptop does this weird glitchy thing sometimes. Right, we're back to here. Okay, so we're down to here. 3x equals -3x plus 6. Next, I need to combine up all my x terms. So I'm going to add 3x to both sides. So here I've added 1 to both sides. Now I'm going to add 3x. That's going to give me 6x here. But over here, -3x plus 3x gives me 0x. So we get 6x equals 6. And we divide both sides by 6, and we get x is equal to 1. Then we take that x value and we put it back into either of the y values. And it doesn't matter because that's the whole point, right? So 3 times 1 take away 1 is equal to 2. And you can see that what we've done is with algebra now, we've got the coordinates of that intersection point. Okay, so that was for doing A and B. Let's now do A and D. which is going to be nice and easy. A and D, we'll just clean up some of this stuff. Let's see what the answer is just using looking at the graph. Well, here's A, here's line A, and here's line D. Let's see. Is it an easy one? Yes, it is an easy one. It is going to meet, those two lines are going to meet at 0, -1. Now let's see how we get there with algebra. We have 3x minus 1 is equal to -1. That means that if I add 1 to both sides, I get 3x minus 1 plus 1 equals -1 plus 1. 3x is equal to 0. Divide both sides by 3, and x is still equal to 0. X is equal to 0, and we know that y has to equal -1. So the coordinates of the meeting point for those two are 0, -1. I'm going to stop the video. Let me see. Am I going to do one more? Maybe. I'm going to stop here because the ones with the fractional stuff are quite tricky and I want to do them in a separate video. So I'm going to pause it here. If you're going well with this and you're confident with your algebra, what I suggest you do is now you start trying to figure out the intersection between B and C, where you've got a fractional gradient, and then C and E, or A and E, and so on. So anything involving lines E or line C or both. And I'll be back with video 7 doing that shortly. But I think that's probably enough for most Year 9's brains right now.